Hello and welcome back to a new nano MOOC of Networking Basics 2. In this video, we will dive into the world of the Internet Protocol, commonly known as IP. The Internet Protocol is a so-called Layer 3 protocol according to the TCP/IP stack explained in previous courses. In Layer 3, data units here are called packets, and the purpose of this layer is to provide end-to-end, source-to-destination transport. For example, from here, the source would be Germany, to the destination, for example in South Africa if you want to transfer data to South Africa. As an independent layer, we need our own addresses for the systems to communicate at the IP level. Currently there are two protocol versions of IP in use nowadays. The one called IP version 4, old but widely deployed, and a newer one who is called IP version 6, in expansion. Let's start with IP version 4 and explaining its IPv4 packet structure. As usual, we have a header and a payload. The IPv4 header starts with a version number which is, of course, 4, and a length field of the header. Next comes the so-called time to live, or TTL field. This is a counter which tells you how many Reuters an IP packet can travel before being automatically discarded. This prevents IP packets from flowing forever on the internet. Then we have a protocol field, and this is similar to the type field we saw in the Ethernet header. It informs about the kind of payload contained. A source and destination IPv4 addresses are next. For example, IPv4 addresses are 32 bits in length. The next field is a so-called optional, which means that it might be there or not. The version number 5 was reserved for a protocol called the Internet Stream Protocol. It never took off. But since the version number was used, they jumped to the next number and called the next IPv6. Let's talk about IPv4 first because probably some of you are already familiar with them. IPv4 addresses are 32 bits in length, and are usually represented by numbers with dots in between. IPv4 addresses, as I said, are 32 bits in length. This means there are a high number of addresses, about 4 billion addresses. Amazing? Even more amazing is that they have been all already handed out to internet providers and end users and practically finished. That's one of the reasons of having now IPv6, which is not in fact so new, first published in 1995. The IPv4 was first launched in 1981. However, you must ask yourself about the IP version 5, right? The version number 5 was reserved for an experimental protocol called the Internet Stream Protocol in 1979. It never took off. But since the version number was used, they decided to use the next number when designing the new IP protocol, which then was called IPv6, first published in 1995 and finally launched in 2012. IPv6 addresses are 128-bit in length. That means there are a really large number of possible addresses. We used to write IPv6 addresses using hexadecimal numbers, so 0 to 9 and then 8 to F, separated by colons instead of dots. A double colon means fill up with zeros. So all these three addresses we show here are the same address. As well as in IPv4, some IPv6 addresses are reserved and not usable. Let's see the IPv6 structure of the packet. The header in IPv6 has a fixed size of 40 bytes, which makes processing very easy and fast. Also, the header looks less complicated. We have at the beginning the version number as before, some flag and label fields. We also have the payload length only. Since the header has a fixed length of 40 bytes, there is no need anymore for a header length field. Then we have the so-called next header field because IPv6 allows extending the header with optional additional headers. The hop limit field replaces the time to live from the IPv4. It works on the same way as IPv4 to avoid packets traveling forever on the net. The addresses fields that are now 128 bits long to give enough space to grow up in number of hosts for a long time. As a summary of this video, there are two Layer 3 protocols on the IP layer, IPv4 and IPv6, and they coexist. They are both heavily used. IP packets, they have a header and a payload. And of course IPv4 and IPv6 headers, they are different, but both have and contain source and destination IP addresses. Where IPv4 addresses are 32 bits long and IPv6 addresses are 128 bits long. And the payload can yet of course be another upper layer protocol. Many thanks and see you on the next video.